Good morning, everyone, and welcome. My name is Chuck Clark. I'm with Enterprise Automation. I'm the Business Development Manager here. And today we've got a fairly short, concise webinar on high-performance HMI. This is my first time doing a Zoom webinar, so please bear with me. Some of the controls I can't see. So we will get started. I have with me Kelvin Lee. Kelvin is one of our controls engineers here at Enterprise Automation, and he will be doing the live demo portion of our presentation. So without further ado, I'm going to go ahead and fire up the presentation. Just a few short slides to give you kind of a high-level overview of what high-performance HMI is. And then from there, Kelvin will dive into a live demo. So again, bear with me, guys, while I get things going here. Okay. So as I said, today we're going to be talking about high-performance HMI, applying contextualized HMI design standards. With our demonstration, we're using System Platform and OMI. Just a little bit of information about Enterprise Automation. We are a full-service integration and automation consulting firm serving a variety of process-driven industries, including water, wastewater, oil and gas, life sciences, material handling, and energy. We have some testimonials from several of our very good customers here in Southern and Central California. And as you can see, these are just a few of the clients that represent the various vertical industries that we currently operate in. Wastewater, water treatment, life sciences, water distribution, and industrial oil and gas.
Chuck.
Yes.
You're still in the presenter view right now.
Am I really? Okay, let's try this again. We work with all of the major brands, more specifically with AVEVA and Schneider Electric. We are a master alliance partner with Schneider Electric, and we are endorsed, we're endorsed with AVEVA on several of their software platforms. But we do support a lot of the other control platforms that are out there from Rockwell, Siemens, Emerson, G, just to name a few. So let's get into it. So why would you want to build a high-performance HMI? So creating situational awareness. Basically, you're enhancing operator awareness of changing conditions. Lower density of on-screen information. Minimize the amount of information that's going to be on the screen. Too much clutter can distract an operator from conditions that are rapidly changing around them. Ergonomics. So if you reduce the amount of clutter, the amount of objects, the varying color definitions and so forth, it's a little bit easier on the eye, especially if you're sitting there for long periods of time. Clearer alarms. Alarm indications can be in multiple ways. It can be a symbol, it can be a color change, it can be a number. And as we go into our demo, you're going to see how we've applied that as well. And then contextualized data. So it's the context of the data versus a raw data display. So if you just have a number displayed on the screen, it really doesn't tell you if it's below low limit, if it's at high limit. So contextualizing it to give an operator an idea of what's happening with this display and what does it really mean. So high-performance HMI is the industry answer for a standardized, easy to use, and more productive HMI graphics system. So a properly designed HMI will support very smooth, stable operation of the process, as well as notify an operator of any conditions that may be outside of what would be considered a normal condition. Design requirements. Early HMIs really were very simple depictions of a P&ID of the process that they were either controlling and monitoring. This was mostly the limitations of the computing and graphics power at the time, but with the enhancements to that, a lot of graphic screens have become quite animated, if you will, and look more like cartoons. But that can be very distracting to an operator, especially in an abnormal or emergency condition. So the ISA came out with ISA 101, the HMI design standard. This started back in 2003. The International Society of Automation, or ISA, commissioned a working group of end users, operators, engineers, and others to basically get together and lay the groundwork for the standard. And finally, in 2015, 12 years later, they published the ISA 101 HMI design standard. It's a set of guidelines, principles, and philosophies for developing graphics on a process HMI. Contextualize graphics and data, and that's really what we're going to be focusing on today. This standard is meant to create a more functional, easy to understand, and information-driven operator interface, and that's information over data. So what are some of the key considerations that you need to consider when doing a high-performance HMI? Number one, proper use of color. So moving away from the intense and colorful graphics, the high-performance HMI is developed in grayscale, with color really intended to be more of an attention getter. Gone are the days of red and green to indicate whether it's running or not, on or off. In a grayscale screen, the use of color is meant to indicate an abnormal situation very quickly. Now, this has been shown to that the new use of color alone has resulted in approximately 48% improvement in detecting abnormal situations before alarms occur. Second thing to consider is, as I said earlier, information versus data. Many HMIs are going to have dozens or more of data points visible on the screen, but nothing for an operator to determine what the data means. There's no context to it. You know, are you approaching a high limit? Are you at a low limit? Raw data readouts, again, have little to no context to actual status. By utilizing an indicator of normal range with a process variable, the operator can make a quick decision to take action to correct a situation that is trending away from what would be considered normal. Talking about embedded trend displays. Traditionally, the trend display has been a separate screen that you would have to call up to take a look to see what has been happening over a set period of time. By embedding them within the graphics of your screens, the operator will be able to take a look and see what's actually happening and what has happened while looking at the actual process in operation. So the trends are always visible. The operator's got a quick overview of historical data, can evaluate for any necessary adjustments before a situation can occur. That can be time consuming and costly mistakes can now be avoided. Next one is simple screens. Keep it simple. Keep the screen simple and uncluttered. A simple depiction of a vessel with a valve and a pump is all that's necessary. Also use easy to find navigation buttons that will take the operator to the next step in the overall process. And then high performance color. And I'm really not talking about applying color, it's more in the way that the screen is laid out. So there's no need to show bulkhead fittings, flanges, or non-essential 3D piping objects. They just add additional clutter to the screen. Using an ISA valve and pump symbol and using a line to depict process flow are the standard now. High performance HMI will say dark gray status for a pump that is stopped and white for a pump that is run. Again, we're getting away from that red and green indicating running or not running. For a pump that does not send feedback to a SCADA, it will be depicted as medium gray. Now, again, these are just guidelines and suggestions for the standard. So some examples. I have an example screen here utilizing grayscale color as well as data with context to status indicating, whether it's in or out of the standard operating range. Embedded trends within the actual object. As you can see, we've got a vessel here. In a traditional HMI, the level indicators that are on the right-hand side in blue would occupy the entire vessel. It's not necessary. By embedding that trend in there, so you can see historical data as well as the actual current values. And again, keeping simple screens, not the 3D clutter that we've had in the past. And high performance color to indicate an abnormal condition, generally an alarm condition. So let's talk a little bit about the display hierarchy. So proper display hierarchy is critical to a high performance HMI. So there's 4 levels. Level 1 is the overall situational awareness. It's used for looking at the overall operation of what's happening in your process. Level 2 is the detailed view. It's a screen that the operator can use to access smaller and more detailed view than the overall level from 1. You could call it a subsystem or even a process in greater detail than level 1. Level 3 is getting into the equipment details, such as a pump or a valve. It can also include more detailed data on that particular process, drilling down into it. And again, as we get into the demo, Kelvin is going to show you that level of detail. And then finally, level 4, which is the diagnostic screen. This gives the operator access to very detailed information on the process and devices for troubleshooting purposes. And if you'd like to do a little bit more of a deep dive into reading, you can go to Amazon. And a lot of the information I got here was from the SA 101 standard as well as the high performance HMI handbook. And if anyone wants that link, I can send it to you as well. But it is on Amazon. Well, that's the end of the boring slides. I will turn it over to Kelvin now to do the demo. And I'm going to stop sharing my screen, Kelvin, and you can take over.
Okay. So here we have what our implementation of a high performance HMI with situational awareness involved. So what we see is basically no color, everything is in grayscale. We have trends for all the relevant information. We basically pick and choose what we want to show and what we don't want to show. The intent is that an operator can just look at this and see only the relevant stuff in an overview. Then we have multiple layers that as we drill down, we do get more information. So for the RO trains, for example, we can click into the RO trains area, and then we get just a little bit more information. And then going into each individual train here, we get additional information, a little bit more of a traditional PNID style layout. So we have just a more traditional look and feel that operators might be used to. But again, we noticed that there is basically no color on here. Everything is simple. There is no question basically of what information you're looking for. Something else that we implement here is you can quickly, as an operator, look and see how your system is performing. So without prior knowledge to the process, you can look at the graphs here and see that, okay, I have a gray box and a black indicator. So the gray box is my ideal performance area. Basically, you can map it to your set points. So your alarm set points. So if I'm within my alarm set points, that's my ideal operating range. So over here, I'm at 79% recovery ratio. Without prior knowledge to the process, I can see that, yeah, that's actually where I want it to be, because as I zoom in real quick, we see that the black dot is within that gray box, almost in the middle. Over here, we're kind of getting on the border of maybe getting too low, but again, I'm within the range. Traditionally, if you just have an analog readout, you would have to go into an alarm page or know the process to see if this number 14.6 is good. You have no context behind it. what we try to do here is basically just look at this and then see very quickly how everything is performing without too much involvement, too much training required. To demo, the next thing we want to demo is going to be the alarms. So if I trigger an alarm, we can very quickly see where the alarm is going to be coming from. Okay, so if I expand the window a little bit, we'll see the alarm banner at the bottom. I have a permeate conductivity high alarm. And right away, because colors mean something here, I see that there's a yellow box around train A. I can click train A, go into it, and I'll see a yellow box around permeate conductivity. So from a distance, you're not distracted by any other colors. You're not distracted by any other information. Everything you need is, everything that's pertinent is laid out easily visible. So, okay, I have a problem here. I can address it. I can do whatever I need. And it follows through here as well. In a system like OMI, there's multiple panes that you can navigate through everything. And that's useful when we go into another type of alarm. So another alarm demo I have here is this one, which now we'll see two different styles. So two different priorities. So we have a higher priority, priority 1, and it's in red. Again, it very quickly draws your attention to this section right here. So I see two different alarms. I, as an operator, can say, okay, I'm gonna go to the higher priority one because that's what draws my attention most. It's the bright red one. I come here and then I look on the big screen. I see that, all right, it has to do with this tank. And here are my set point levels, and I am below the low here. So I have an issue that I want to address and try to figure that out. But at the same time, I do have multiple alarms going on. And in the OMI program, the way we have it set up is we have the main screen, but we always have an overview screen here that links the area. So I see there is multiple issues going on with this area. And I can quickly go navigate because these two came up at the same time. So I'm assuming that they are related. So I'm just going to go and click this one. And I'll see that, okay, well, this one just happens to be the level being low here as well. Address it as needed, and then I can just go ahead and clear it out, acknowledge everything. And once the alarms are no longer active, I can just acknowledge it. And then I'm back to a nice grayscale. Everything is operating as intended. Nothing's out of the ordinary. And I'm happy as an operator. Everybody's happy because things are performing optimally. And no distractions. So that's the basics with OMI or with situational awareness HMIs. But with some of the newer product as well, we also get into added benefits. So OMI natively works really well with situational awareness. It also gives us the ability to create very powerful standards in such a way that we can very quickly add new wells. So for example, we see here that I have 11 wells. Let me go ahead and get rid of that piece right there. So in the PLC program, as it stands, we have 11 wells, SDF 1 through 11. In the front end, if I was to design everything with very robust standards, which we have here, I can say, all right, in the future, I've added well 12. Typically, that's a big process to have it integrated, but I've created standards here. So now I can just say, all right, I will add a SDF well 12. I've created a well template in our PLC program, and this has given us the ability to lay out everything, including all the I/O for the well. There's analog valves, pumps, pressure sensors, level transducers, and everything else that's associated with the well. So by simply adding SDF 12 on here to my as part of my standard, I can then come into the well 12 or the well simulator program, which is what we're using here for the demo. I can copy the code for another well. So this is going to be the process code behind it. And then just change this tag to my standard that I've created and program it into the PLC. So this is the backend side. The PLC and the HMI has been programmed in such a way that they're related and it makes expansion very quick and easy. So I'm literally adding an additional well live. So I'm gonna transfer it to the PLC. And as it's building the PLC program, I'm going to go into Wonderware. And we can see here that in the well overview, we have 11 wells. And it's set up in a way that it can automatically add the 12th well in with very little config. So I'm going to go into my toolbox here, and I have the well, we call it the source. We have a well object. I'm just going to create a new instance of that well object. And as it's doing that in the background, I can go back to the PLC program and let it finish what it needs to do. So I've stopped the PLC now. And if we come back here just for fun, we can see that there's a lot of broken things. Because the PLC has stopped, it's lost communication. So let's check on the status of everything. It's still creating the instance. But again, this is doing everything that would typically take weeks, if not months of programming. So I have the new well here. I'm going to call it SDF 12 again. And right now, what it's doing is it's generating all the tags, generating all the links to the PLC automatically. So HMI configuration, we didn't need to create tags ourselves. We didn't need to draw anything new. We didn't need to do modifications to the overview. It's doing that all in the background right now with just a few clicks and renaming of objects. So now I have that in an unassigned area. I'm going to assign it to the source. And then I'm just going to deploy it. Over here, I'm going to run the new build since I've added well 12. And go back to the HMI, and the PLC has started up. We'll see a whole bunch of alarms everywhere because the plant is in a shutdown state. So for situation awareness, we see that there is definitely problems based on color. gonna log in. And I'm just gonna start the simulator so we can get rid of all the fake alarms right now. And the well has been deployed. I need to move the communications device for the new well. So that's all of this equipment here. Right. While I'm doing that, I'm going to deploy the objects on the screen as well. So again, because I've put it here, the screen is automatically populated. And it has noticed that there's an update to the screen. And now within minutes, let's go ahead and acknowledge all the alarms. But within minutes, we have SDF12 here. We have it here as well. And we have all the graphics associated with it generated almost automatically with just a little bit of configuration in the back end. The communication still hasn't gone through yet because we need to move devices. And it's just acting up very slightly right now. But it would typically communicate automatically as all the tags have been created based on our templates. So this is the power of both situational awareness and InTouch OMI, in that as long as you create everything in the front end, plan everything out, you can generate new equipment very quickly. And you can also see all the styles and everything matches. We still have overviews and detail level, and everything basically navigates automatically, and all these screens get generated automatically. And everything is simple. The alarms and everything also work the same way. So that's my live demo. That's the presentation for this portion. Do we have any questions or anything about this, or anything you guys wanted to see? If so, you can feel free to use the questions and answers section to post anything or request anything. Chuck, you can go ahead and take over again.
Okay. Can you hear me, Kelvin?
I can.
Okay, good, good. I'm gonna go ahead and leave this screen up because this is pretty powerful. I like this stuff. As Kelvin said, if you have any questions, please feel free to post it here, or if something comes to mind later, feel free to email us, and we'll get back to you quickly in response to your questions. But we do appreciate you taking the time out of your day to visit us here, take a look at high performance contextualized HMI. And generally, this is where we are seeing the industries going. And I say industries plural because it's happening in a multitude of industries. And to use an analogy, you're finding, let's take an airplane cockpit, for example, a commercial airliner. They've been working on this for years. minimize the amount of clutter on the screen so that you can immediately react to something that is out of the normal. I mean, in that case, it's pretty extreme, but let's take it down to the level that we're at. And this is a very powerful tool that you have at your disposal with AVEVA and OMI. So I don't see any questions, so we'll go ahead and close out now. But again, Enterprise Automation appreciates you visiting us and sitting through our webinar. Again, if you have any questions, feel free to email us. Otherwise, have a great day, guys.